I have an audience here. Okay, so what we're going to do is we're going to do exercise 10 on the temperature and heat. Section 1, 11-1, temperature and expansion, we're not doing that. However, we are doing the second section, and that is 11-2, heat. Okay, now, if you've done problems in that section, example problems and problems 8 and 9, you're pretty familiar with this. The heat gained plus the heat lost equals 0. Now, we know that the heat gained or lost is going to be the mass times the change in temperature. Remember, it's always final minus initial, always. Times the specific heat capacity is going to be, that's heat, that's the expression for heat. It says right in the beginning of that, it says delta Q equals MC delta T. I like to put delta T in the middle, just as a nice separation between M and C. Anyway, so this is the problem. We're doing exercise 10. Phoebe's insulated foam cup is filled with 0.15 kilograms of coffee. So here's the coffee, 0.015 kilograms. That's the mass of the coffee. And then it's too hot to drink, so she adds 0.01 kilograms of milk. 0.01 kilograms of milk. And then, and the milk is at 5 degrees Celsius, and the coffee is at 70 degrees Celsius. Now, the cold milk is going to cool down the hot coffee. So the heat that is gained is going to be by the milk. So this is the milk side. And the coffee will lose heat. The heat from the coffee will go into the milk. So the coffee is the heat lost side. So this is the milk side, this is the coffee side. Here are the measurements, 3,800 joules per kilogram degree Celsius. That's the specific heat capacity of milk. And 4.187 joules per kilogram degree Celsius is the specific heat for water. Okay. Initial temperature 5 degrees Celsius for milk, initial temperature 70 degrees Celsius for water. So, because heat gain plus heat lost equals 0, heat gain is going to equal negative heat lost. That's negative sign is going to become important. So then I expand these and I get M times the quantity T final minus T initial times the specific heat capacity equals negative this expression, mass temperature final minus temperature initial times the specific heat capacity. Now if you look over here, remember from your basic algebra, if I have a quantity x minus y, and I take the additive inverse of x minus y, that's going to equal negative x plus y, or simply y minus x. Simple stuff. Okay. So, I'm going to reverse this, and I get Ti minus Tf. So now, here are all my values. Here's my equation here, my final equation here, and I'm going to plug in. So plug in 0.01 for the mass, 3,800 for the specific heat capacity, 5 degrees for the initial, and then that's on the milk side. On the coffee side, it's 0.15 kilograms for the mass, 70 is the initial temperature of the coffee minus TF, and then 4187 is the specific heat capacity for the water. Okay, so this times this is going to be 38. This times this is going to be 628. And then divide through by 38. So 628 divided by 38 is 1653. Leave that alone. 1653 times 70 is going to be 1157 minus 1653 TF. So that's where we're at. That's really all I have board space for when I set this up. So what I'm going to do is I'm going to erase the top. I'm going to erase some of this, and then we'll continue that. Okay, so I'm going to erase all of this. If you need to see it, you can rewind the video. Okay, and I'm going to erase everything here, here, here. I'll leave those two lines. Well, no, let's just get rid of that. So now, I work this out somewhere. I thought I did. I don't have the paper. Oh, here it is. Okay, so, yeah, I'm filming, but thank you. Okay, so now, let's look at this. So, where are we? So now, I can add 5 to both sides. So I have TF equals 1162 minus 1653 TF. Is that correct? And then I want to add this to both sides, correct? So this is really 1, right? That's a 1. That's a 1. That's 1 TF, right? So if I add that, that's 17.53 TF equals 1162. So TF would equal 1162 divided by 1753, and that's going to be 66.3 degrees Celsius. Okay? The paper says, I don't know, I think it says 66 degrees Celsius. So it does cool it off a little bit, but not that much. Okay, and that's it. So that's really one of the harder ones to do for specific heat capacity. I'll do a few more, but that's it. Okay?